please. Let me get there we
It's
go.
just above where you.
I am. I got it. I got it. All right, here we go. This is a discussion on plate solving and whoops, I lost my place. Here we go. And as I said, following Mark, this is the old-fashioned way, but it works, at least for me. This is I give an example here when you're trying to do an observation when you're in a circumstance where you don't have a finder scope, a red dot finder, a laser pointer, and no computer control of the mount, using a Windows 11 laptop and Sharpcap Pro. And I used plate solving to solve this particular problem. Plate solving is matching patterns formed by stars in an image with patterns of stars generated from star catalogs to determine the coordinates of the image. And they use data catalog that are star catalog data organized by magnitude into collections called indices so that you can specify sufficient information to allow the software to limit the search to those sets of data, or you can limit the data so that is searched to those that are most likely to match the image. So you don't waste time searching through stuff that it's not going to work. That's not going to work. Plate solving was matching images on glass photos, the plates to star catalogs or to other plates. And you would determine plate orientation, scale, plate constants. As a graduate student, I got the fun of taking a class on how to do that. You find use of that information then to annotate stars that were not in the star catalog to give you coordinates that you then could use to find the astrometric positions of comets and asteroids. It was pretty tedious and time consuming because we were doing it by hand. And there were some methods that were generated to do some of that by computer as star catalogs became more and more computerized. But this was updated under a contract from I think it was NSF to develop and replace the new software to replace the existing computer-based plate solving with a technique that used what are called quads, indices of quads. They're four-cornered shapes formed by stars, sort of like mini constellations. And then you use those to compare with similar shapes extracted from the digital images that the plate solver is presented. And the software developers, since it was a government contract, uh, placed all the data and software in the public domain, and they now still run uh, a plate solving service at nova.astrometry.net. So if you have a plate, it's very helpful to go there to nova.astrometry and have it tell you what your plate size and orientation is. So then you can take that back to make sure your software has the correct information to do efficient plate solving. And there's some references at the end of this on plate solver development. Once this information was available in the public domain, professional hobby software developers built various packages to provide plate solvers to individual observers for a relatively low cost or even free based on these APIs. In Sharpcap, there are a number of different options available. Astro Tortilla was once upon a time a favorite one that many of us started with, was our first experience with plate solving. There were detailed instructions on how to do it online and so forth, but it hasn't been maintained since something like 2012. So, and it doesn't work anymore under Windows 11. There's a couple others, Answer, All Star Plate Solver, Stacker, and I can't remember I think it's Stacker is the S. Um, they require programs that set up external to Sharpcap for support to get the software to work. And then there's a new one in Sharpcap itself called SharpSolve. It doesn't require any external program setup, and it doesn't execute outside of Sharpcap, but it's very easy to use. It's quick. There's two more options, PlateSolve 2 and PlateSolve 3, that you can get to through Nina. There's a section in the Sharpcap manual called Finding, Identifying, and Framing Targets that gives pretty detailed explanations of all of these. as well as what plate solving is and the options available. And this is the menu that Sharpcap has for the plate solver options, which you go through Sharpcap settings to get to, where you select which plate solver you wish to use. And I have switched to pretty much only using SharpSolve. You can test that it works for your system, and you can say what it is you want it to do. In this particular case, I usually have it set to sync the mount and recenter to the target when I use a plate solver. And then you set the focal length of the telescope, and it assumes that you are using a ASCOM to control your scope as the broker between the scope control and the Sharpcap. And ASCOM can have the details about the mount, or you can specify what the focal length is. You also can limit how far the search goes. And I'm not quite sure if this really helps the 8-bit images to plate solver application. I click it because Mark Bowie once said to do that, but I don't know if it makes any difference. And then SharpSolve has two sets of data, one for the wide, very wide field, half a degree, and the other for a slightly smaller wide field, quarter degree, where you actually need to add an extra index file, which I have. And so it's operational with the 14-inch. Now I asked with the 14-inch, we have a oops, oh darn, previous. With the 14-inch, we have a hyperstar. But the example I'm going to present is a naked scope, I said, which has, as I said, no finder, no red dot, no laser pointer, setting circles, just the scope, a camera with GPS and a time tagger, Sharpcap, and a laptop. And I use the Sharpcap plate solver. And in this case, this was the C11 on a mount borrowed from Ted Blank, Skywatcher AZ EQ6 Pro in Alta Azimuth. It also can be set to equatorial, but since this was a mount we were not familiar with, we decided not to try to put it into equatorial mode for fear we would mess it up. And the camera I was using was the Zuo ASI 178. The red cable connects to the laptop, which is back here hiding behind the tube. And that was the only connection. There's no connection to the mount. The mount was controlled entirely by its hand paddle. So the Sharpcap tools available for use are given in the tools menu. And for plate solving, when you have no mount control, there are two available. One is the plate solve only, which I use to see whether or not everything is set up properly and there are enough stars to do a plate solve. And this push-to assistant. And the push-to assistant is something fairly new within Sharpcap, and it's very handy. So I use the push-to align the mount, find the target, and works for any mount, go-to, non-go-to, Altaz, equatorial, powered, unpowered. And here is an example of what it looks like. We aligned with Antares and Vega, and you can see in here, it says what target are you looking for? And this one is Vega, I specified. I'd already gone to Antares, and now it's going on to the second star for aligning the scope. The one issue that we had was that the alignment stars needed to be both in the hand-paddled star catalog as an alignment star and in the Sharpcap catalog. And we discovered that there were, at home when we were practicing this, there was ENIF, for example, was available as a alignment star in the hand paddle, but when we were on site, ENIF was not available. I'm not exactly sure why, but that's just the way the scope works. But this process goes very quickly when the scope is easy to move with a hand paddle or a push. Not all of our scopes are our mounts are truly easy to move like that, but this particular one was quite easy. And David commented that I had the scope in Terry's before he could see it in the sky, because this was an early evening event, and we were starting absolutely as soon as we could detect stars in the field of view of the camera. To choose a target from the Sharpcap catalog, you use the full catalog button that launches the select a target window, which will appear like this. And of course, there's a huge number of things, but I'm only interested in stars. And then you give the name of the star you're searching for, or the HIP, I think is another option. Most of the stars in this particular default catalog are mostly brighter than 8th magnitude. Hipparchus catalog stars are identified by their number, and brighter ones are identified by the common name or the Bayer designation, the Greek alphabet. So we specified the target in the evening we were going for Didymos by right ascension and declination, which in Sharpcap you just type in the elements. It tells you what your coordinates are being referenced as. So if you made a mistake, you can tell. And then hit start. And you can see still back up in here is Nunki. That was the third star we used for a PAE, position enhancement target. So here was the details. That Zuo camera found the target, was not sensitive enough to reliably observe this very short occultation, which was less than 1/10 of a second. And so our plan was to remove the Zuo and install a Waytec 910. Now, that worked in practice, but practice isn't the real thing. The Zuo took a little more force than we expected, and we knocked ourselves off target. We did not get back on target until after the event, so we were pretty unhappy about that. Slightly, softened by the fact that our observing location was outside the path determined by others who did see the event. So here's a little more plate solving information. SharpSolve only works with Sharpcap, but it needs no extra setup or preparation. Other plate solvers require external software for their operation, but they also have other functions, such as you can register and stack images. And plate solvers operate on digital images, not video. iMovie will generate a finer image from a video that can be used after the fact, but that's pretty clunky to try to do that while you're actually observing. I'm not sure it's worthwhile trying. A good plate solving requires about 100 stars. Some plate solvers will say they can work on as few as 5 or 6, but it really requires a lot more than that. The extraction process we find is very good at finding stars in images that we may not be able to see on the screen. So it'll tell you how many it finds, and it's kind of surprising sometimes. The plate solvers need to know the scope, focal length, or image size. The nova.astrometry.net, as I said, will provide that if you give an image to process, and then you'll have the information for future use. Just last night, we tried to observe an occultation of 2000. It was 2001 ZQ6, I think it's, or 206, I'm sorry, ZQ206. And so I snapped a screenshot of the go-to screen when Sharpcap is in control, what it looks like. In this particular case, I'm looking for Capella. So here's Capella, and it finds Capella in the target in the catalog, and then it moves to Capella. And you can see the streak back here. It's actually moving as I snap the screen. So this goes through all these particular steps and gave us Capella. I didn't have time to put the Capella image on this particular presentation, but yes, it did give us Capella. The Sharpcap user manual is a great reference for future information on using Sharpcap with plate solving. It's under the section Finding, Identifying, and Framing Targets, and you can get to the user manual under the Sharpcap Help button. And also it gives the websites for the different plate solvers in the user manual. Another place, of course, is, as I've been saying, is nova.astrometry.net and its associated GitHub. You can go to the Read Docs section for astrometry.net and get some information. And this paper is a very interesting paper from the group of people that actually developed this astrometry.net. And they made the comment at some point either in the paper or in a presentation I've seen that this was an attempt to put some real science behind the techniques that they used to actually make this work. And if you're interested in some of the older uses, older plate solving that was done in days before computers or just at the very beginning, look in the older textbooks on astrometry. One of them, the Smart's textbook on spherical astronomy. So, and this image of the Ring Nebula is something we took with our 14-inch. So if you have any questions, I will stop sharing. No, it's not a color picture. Yeah, David's muttering behind me. That's not a color picture, so it's not very that one of the Ring Nebula is not pretty. Well, we decided that we would not go to color cameras because it's a bit of a rabbit hole. You spend half your life doing nothing but taking pictures, and we have other things we need to do, so we haven't done that. Are there any questions, or is it? By the way, I also should say we do own 2 Astrids and very much appreciate the work that has been done in developing them. And Mark has it's just been fabulous. But we also have a GPS camera. We have a 14-inch telescope in a dome. In a roll-off roof observatory. So we want to use those too.
How long does it take you to find a target using the Sharpcap astrometry function?
Very quickly. Yeah, as David said, I was on target before he could actually see the star in the sky.
And Sharpcap, does that have its own database of star positions, or do you have to be online?
It has its own database of star positions. Yes, that's in some cases it goes to 8th magnitude, but it's not quite complete to 8th magnitude. It doesn't actually have all the Hipparchus catalog, so it does misses some of the fainter ones. I think there is an option if you want, you can add more star catalog data. I find that I don't really need that because you can also type in the coordinates. And that works too.
You can also copy and paste the coordinates from Occult Watcher or Cloud or something like that. You do have to maybe update it you might have to delete a few of the extra characters, but you can copy and paste rather than having to type it and maybe make an error in the numbers.
Yeah, that I've done that too. But in terms of speed of all of this, last night, for example, looking for this occultation for 2001 CQ206, I realized 20 minutes before the event that I had neglected to get started. So I grabbed the laptop, ran out the door with a flashlight and a bottle of water and a laptop you need the bottle of water. It was 95 degrees at midnight. And was on target in 15 minutes. And that includes opening the observatory, getting the cover off the telescope, getting it connected up to the laptop, and then finding the target.
Roger, for the recent Didymos event, I used Sharpcap's plate solving with the UHY camera in order to get on target. Sunset was about 7:15. I was on the target by 7:45. It was quite easy. Basically, it didn't take any long at all. Once the sky got dark enough, it was very quick.
Yeah, even without having the control of the telescope, even with that push to plate solve. It was very quick. Yeah, the only problem we had was that um, we knocked the scope off the target, trying to switch to a camera that was actually going to be able to record such a faint target at such a short occultation. And well, yeah.
Does Sharpcap allow you to upload the software onto more than one computer once you have purchased the software?
Yes, I have it on like 4 computers or 5, I think. Sharpcap has a licensing, but Sharpcap without the some of the features is free. The Sharpcap Pro, which I use because I think that you need that one for the computer control, it's fairly inexpensive. It's in pounds, but I think the last time with the currency rate it was something like $11.50 or something like that. And you get a license key, which you then just paste into however many copies of Sharpcap you happen to have access to. So,
Okay, well, that's convenient.
yeah.
Any other questions for Joan? Okay, why don't we move on? Is Michael Camilleri here?
Yes, I'm here.